thing, man. All right. What questions do you have off of 4, 5, 14, or 17?
4.
4?
Yeah.
Okay. Did you think it was not a function? Ooh, that was louder than.
Yeah, I thought it was not funny because
Say again.
I thought it was not funny because I thought like the output or whatever it is, like the top number has to be the same to equal 25 on the bottom number.
So remind me what the definition of a function is.
Okay.
Hold
An
on,
input has a different
A relation
output.
such that each input maps to only one output.
Yes.
Right, we should have that definition
One
down.
and only.
One and
So
only one.
a relation such that
Hydro peak. I mean, glass.
each input maps to one and only one output. Alright, so we have that written on the board. We're going to come back to that in a second. So tell me this, Corel. Negative 12. What does it map to?
25.
Does it map to anything else?
No, do 25.
Okay. Negative 8.
25.
Negative 6.
25.
Negative 4.
25.
Do any of those inputs map to more than one output?
No.
And it's a function. The definition of a function does not care if an output is repeated, it's if an input is repeated.
So if you were to put the 25 as the x instead of the f of x, then it would have not been a function.
Right. Or, Corel, if it had been this, actually that still maps to the same thing.
Yeah, but you're talking like 26 or something.
But if it had been like that, now negative 12 maps to 25, and negative 12 also maps to 13, that would not be a function.
Oh, yeah, sure.
So the range values can repeat, the domain values cannot. Does that make sense?
Yes.
Cool. So that's a great question, and that's why we have these practices before the actual homework, for accuracy. Any other questions?
Why can't we do it in the dark? I'm trying myself.
I'm afraid you'll fall asleep.
No.
I start to see one of you falling asleep. Lights come back on.
Oh, it was cool.
That's it. All right. Any other questions?
Wow, I can see the board much better.
Good. Any other questions?
No. No more. I don't think so.
None about 14 or 17.
Yeah. No. Yeah. 14.
I would say most people had questions about 14 all day today. Or about 17, sorry. 14, some people have had questions. Desiree, is it the domain or the range that you have questions about? Or both? Both? So, don't forget, y'all, when we talk about domain, what are we talking about?
Set of all x.
The x-axis thingy.
They said
The
all.
axis.
X value.
My axis.
They said all inputs.
There we go, set of all
Inputs.
inputs.
Oh.
Remember,
It's not that.
usually our input is an x, but we can have other inputs other than x.
It's not all things in the x-axis, because the x-axis goes from.
Well, it's all input, so all x values. Okay? In a similar way, when we say range, what are we referring to?
They said all outputs.
Alright, so usually y values. Okay. And Desiree, what we're going to do is we're going to use that interval notation whenever it's continuous, which these are. Notice the interval notation starts at the minimum value, comma, whatever the maximum value is, right? So when you look here, what is that? Well, yes, but just in general, what is that shape?
Oh, anyway.
Right. That means it's going to keep going up, but it's also going to keep going to the,
Infinity valley.
what is that way?
Left.
Left. Right, it's going both up and to the left. So when we're talking about domain, it's going to keep going to the left. Those are my x values. What is the lowest x value that it will have? Do you agree? I mean, it'll never stop, so it'll go all the way down to negative infinity. And then we can never equal an infinity, so it's always the parentheses there. Same thing here, up, but to the right, so it's going to positive infinity. Desiree, you good with that? Okay. And then range is the same idea, but with the outputs of the y. So here's my lowest output at -1. Because it's closed point, I can equal it, comma, the maximum of infinity. Yes, ma'am.
Are we gonna go over this sheet?
The review homework, we're gonna do it tomorrow.
Go over?
Just to save a little bit of time, we're just going over this today. And tomorrow's homework, or tonight's homework, you're turning in tomorrow, so we're just gonna go over the review homework tomorrow.
Oh yeah, Miss Kim.
I haven't done any of these because I don't understand.
Well, oh, you're not turning in that sheet, you're not turning in the review homework questions.
Oh, okay.
You're turning in the questions like this tomorrow.
Oh, okay.
Yes, sorry. No, because you still need that sheet over the weekend for Friday night's homework.
Oh, yeah.
All right, number 17, do we have any questions here?
No.
Most people are pretty good with the domain after the previous
Wait,
explanation.
I got that one wrong.
But I would say I'm pretty sure most people got the range wrong.
-6.
I got it right, so my name's Kim.
Oh yeah, Kelsey, if you look, here's -2, -4, so that's -6.
It looks like an 8 on my keyboard.
I know, everyone said that all day today.
What? I thought it was 8, because I got 8 on there too.
But, hey, Corel. Corel. Hey, Corel.
Oh, yeah, I see it.
I'll say 1, 2, 3, going by 2s, that is -6.
Okay.
I got
Why
negative
is
8 in it.
-2 or I got 2 -2s.
Huh?
What?
Hey, wait.
So you wrote it like this,
That is correct, yes, sir.
okay? And,
Oh my gosh, Chris scared me at the door.
Why are you so late to my phone? That's not an answer. Where you been? You've been at the sign machine for 11 minutes. You're not gonna have a conversation once I get the class started. Take a seat. Alright. Shelby, I believe you wrote this as just -2 and put the square brackets around it, didn't you? Okay. But we need to talk about this. This is known as interval notation, correct?
Which one?
Well, trying to use interval notation here and this be interval notation. But what does this comma mean?
It means in between.
Everything in between.
Anything in between.
Is there anything in between -2 and -2?
Oh my gosh, no.
Wait, no.
Definitely no, right? So we're not going to use interval notation here. And so Shelby, we're not going to use square brackets either. Notice if you look at the way I wrote it with the curly brackets. When it's a single number or a set of isolated numbers, discrete numbers, we're going to use that set notation to indicate that it is just that one single number.
Would you count that wrong?
On accuracy check for homework, yes. That's why I made sure we did one of these before you have number 18 for homework tonight.
Hey, Miss Kim.
Sir,
What did that bracket mean again?
which bracket?
The little squiggly bracket.
Curly bracket?
Yeah.
It means the set. So like when you look right here at this function, that output is -2. This output is -2. This output is -2. Heck, even this output is -2. Are there any other outputs other than -2?
No.
No. So then it's just a set, it's a set of one single number, -2.
It's a mathematical systems bracket.
So we do use curly brackets to put a system together, but is this a system?
Yep.
No.
In order to have a system, it has to be more than one. This is known as a set. And also, when we do a system,
They need to
it's
come up
only
with a
one
name for
single
that.
curly bracket.
That name sucks. Is there not like a technical name for that?
Yeah, curly bracket. Yes, ma'am.
On number 18,
What?
which I know we're not, it says, it looks like an 8 again. Is that a 6?
Wait, no. What's
You
the actual
count,
technical
sweetheart,
name
it
for
looked
it?
like a 6.
Is it a 6
You know.
or an 8? It looks like an 8.
Kelsey, that is the clearest 6 I've ever seen.
Oh, I see it
2,
now.
4, 6.
Okay.
Easy, Liz.
Miss Kim,
Yes, sir.
what's the actual technical name for that?
Curly bracket. I'm not kidding.
Why do you ask that every single time I go
No.
over it?
I literally Googled it because I didn't know, and it is called a curly bracket. Just like this is called a square bracket.
Like, get your opinion.
And that is as technical as it gets. I know you don't believe me, but it's true. Oh, the other way, so please notice you can put the set notation with -2. Or you could just indicate every single y value is -2, y equals -2. That would be acceptable for the domain as well, or for the range as well.
Alright.
Okay? Any other questions before we move on?
I'm embarrassed of that.
Going once, going twice, sold. Alright, today's agenda, we're going to look at our objectives, as always, because you got to know what you're trying to learn in order to learn it. And then we're going to start 6.6, how does it grow? We're going to end the day with answering some key questions, as Corel kept pestering me from the understanding check. That's where we're going to end today, Corel. Really quick couple of notes. 6.6, how does it grow? This is a practice understanding task. This is the last task in this unit on quadratic functions. It is 13 questions. It will take longer, but it is to help us really understand quadratics in each of the mathematical representations versus linear and exponential. So I will be pushing on your ideas. I'll be asking you questions, and I'll also give you feedback over the weekend. So I'll collect these from you and give you feedback over the weekend. Excuse me. We will have an understanding check, our second one, on Monday. So be aware of that.
I have 2 tests on Monday.
It's an understanding check.
Oh, same thing.
No, it's not. We will have a test next Thursday or Friday.
Oh my gosh. 2 in the same week?
Next Thursday will be the 29th, next Friday will be the 30th. Okay. Alright, so objectives, right? So don't forget your SMPs. We have the standards for mathematical practice. These are the things we need to be doing so that we can learn these objectives. This is the most important one, and this is probably one of the ones that we need to pay attention to the most. We need, actually I think it's supposed to be 3, not 6. I'll fix that later. But we need to be constructing viable arguments. When you have a valid argument, you are not just saying, this is what I think. An argument needs to be, this is what I think, and here is why. You need to justify, you need to have evidence. By thinking through the evidence, thinking through why you think that's the answer, you're going to learn so much more than just saying, I think blank. But then you also need to listen to the reasoning of others and critique what they are thinking. Earlier today in second period, David and Gay and Michael Chapman were actually talking with each other, and David was like, well, I think I can do point slope. Oh wait, no, I think I can do slope-intercept form for this equation. Michael sat there for a second and he looked at David and he goes, well, can you do that if it's a quadratic? And then David thought there for a second, he's like, wait, it is quadratic. I can't do the point slope form of a line for a quadratic. It was through that discussion that they were able to learn. They weren't disrespectful, they weren't rude, they were just critiquing the reasoning of each other, and that was helping them grow and learn. So that's how we need to operate. That's how you learn the most from each other. So, and then we also need to attend to precision to do these 2 objectives. Desiree, can you read our first objective for us today?
Translate functions into mathematical representations that is not given.
Right. So we're translating functions. We want to be able to move comfortably from one representation to the other, because moving between those representations will help us understand each function a little bit better and make sure that we understand what kind of function it in fact is. Corel, can you read our second objective today?
Is that differentiate?
Yes, sir.
I can't say it now. Linear, exponential, and quadratic functions.
What do I mean by differentiate?
I'll find a difference. I'm just kidding.
Say again?
No, nothing.
Find a difference, is that what you said?
Yeah.
Close. Not find a difference, but
I understand.
determine the difference. Tell the difference. Right? So tell the difference between linear, exponential, and quadratic functions. You got to be able to identify what type of function you're looking at. Say, oh, if we're looking at the graph, that's an exponential curve, or that's a parabola. So it's either exponential function or it's a quadratic function, right? So we need to be able to tell the difference between all these different types of functions, no matter the representation, so that we understand what we're actually working with and looking at. So a couple of things to really quickly talk about. Every single problem on this task, you are required to do 4 different things.
Okay.
First things first. Identify whether or not the relation is a function. We already have a definition up of what a function is.
Yes.
What do I mean by a relation, though?
Like their relationship.
Okay, but there's lots of things that are not functions.
The input maps to 2.
It could.
What do y'all got?
Okay, so I want y'all to, okay, you should have a total of 3 sheets for 6.6.
3?
Yep, I gave out 3 earlier.
You got
Yeah, I got it.
Okay, so really quickly, listen to me on this. Shelby is hitting on something important. She said, well, a relation then maybe is is something that each input maps to more than one output, which that can happen with a relation, but think about what she's saying there of an input is mapping to an output. So the input and the output are related. That's all a relation is. Just like relationship, right? There's a relationship between these things. So when we say relation, we're saying there is some relation, or there's some relationship between values or variables, right? So we're talking about inputs and outputs. Okay, so when we say relation, right, there's just some relationship between values or variables, those inputs and those outputs. I bring that up because I know we talked heavily about functions last year, not as sure as how heavily we talked about relations.
What's the difference between relation and function?
So a relation, there's just some relationship between values and variables, inputs and outputs. But with a function, each input is only going to map to one output.
So, a relation
Yeah.
can or can't be a function?
A function is a special type of relation.
Oh, okay.
Just like a square is a special type of rectangle. Notice how I have pairings between inputs and outputs, right? Could this be a function?
Yes, it could be. Oh, no, it can't.
Which one?
No,
Why not?
because two inputs of the same have different outputs.
Okay, so one input has more than one output. So that is not a function. Is there still a relationship between those inputs and outputs?
I don't know, but
I mean, they're paired together, so there's a relationship. So it is still a relation.
so what's a function that's not a relation look like?
Can't happen.
Okay.
As I said, a function is a special type of relation.
Okay.
It cannot be a function unless it is also a relation. That was a good question. Okay? Now these next two parts, B and C, notice how it says determine if the function is blank. Well, can you determine if the function is linear, exponential, quadratic, or neither if it's not a function? No. So if it's not a function, do you need to do parts B and C? No. Right? So don't do these if relation is not a function. But you should be able to determine if the function is a linear, exponential, quadratic, or neither, right? So you should be able to figure those four things out, or which of those four things is true, either based on the graphical, the tabular, the algebraic, or pictorial even representation that is there. As a part of that, you should be describing the type of growth. What do I mean by a type of growth?
Rate of change.
Yeah. Type of rate of change. That's what I'm referring to there. And then finally, create one more representation for the relation. Personally, I'm always going to recommend that you practice creating an algebraic representation because that is the hardest, but you can always make a table or make a graph as well to help you make the algebraic. It only requires one, but I think everyone agrees that making the algebraic is the hardest, right? So I would practice doing that every single time. Sound good? Kelsey's like, no, Mr. Kinney, I don't like it. But I promise you it'll help you be better prepared for the understanding check and the test.
Alright.
Alright, I'll trust you, I guess, Mr. Kinney. Okay, so go ahead and get started. Well, first off, are there any questions from y'all?
Yes, why must we do this?
Because learning, it matters.
Wait.
It is required. Yeah, it is required. Okay,
What is
so
required? We don't know.
this task,
Oh.
the math stuff that we're learning. So yeah, go ahead and get started with your small group, and we'll get to work.
I have bad news. I was not paying attention to what I was saying.